Hi, everyone. I'm Hao from Washington University in St. Louis. This is the work with my advisor, Sanmay, my lab mates, Lavoie, Sirui, and Professor Betsy Sinclair from Department of Political Science. And our paper is about applying machine technique for analyzing political text data. So political discourse is a very important factor for most of the government in the world. In the US alone, billions of dollars are spent every year in political lobbying and advertising. Language is carefully chosen to influence the public and the lawmakers. Therefore, analyzing political text data is very important. In general, people are particularly interested in following questions. First, how do politicians communicate strategically? For example, do they communicate consistently in different channels? Do they express similar ideology intensity when they debate on the Congress floor and make an announcement on their official website? Second, how does the media reflect political language? Third, are they communicating differently about different types of issues? For example, given a piece of text data, which topic is easier for us to tell the partisanship, economic issues or abortion rights issues? Previous researchers have investigated related problems and made significant contributions. Jessica Shapiro, they measured the political bias of local newspapers in the United States based on congressional speeches. They proposed a statistical model and come up with a partisan phrase list based on congressional speeches and identify the partisanship bias, political bias of local newspapers. And they also find out that it's the reader's preference that drives the media bias. Bakshi, Messing, and Adamic, they investigate users' exposure to the political contents on Facebook. They observe that there is actually a polarization among those content. Third, Budak, Go, and Rao, they quantify media bias using cross-sourcing techniques. They find out that for major media outlets in the United States, they actually cover a wide range of topics which is unrelated to the political bias. Fourth, Jessica Shapiro and Teddy, they measure the polarization based on congressional speeches for members of Congress. And they find out that it's actually easier to identify the political bias of members of Congress. And the polarization for members of Congress is actually higher than before. In this paper, we use and apply machine learning techniques to investigate the following questions in terms of the political text data. First, we try to generalize partisanship across different text domains. We found out that the cross-domain political ideology generalization is surprisingly difficult. The classification and regression model trained based on one domain has poor performance on the other domains. However, the cross-domain partisanship generalization is better for some topic than the other topics. Second, we try to estimate the partisanship for members of Congress. To be more specific, our main problem is, do members of Congress communicate consistently across different channels? Our answer is yes, they express their partisanship consistently in different domains. And no, the within party partisanship intensity is different in different venues. Okay, let's begin with our first problem, partisanship identification across different text domains. To investigate this problem, we designed a round experiment with following three data sets. First one is Congressional record. Congressional record is the speeches delivered by the member of Congress on the floor. And we label all the speeches in this data set with the speaker's partisanship. The second dataset we use is Salon Town Hall dataset. Salon Town Hall is two media websites that are well known as liberal and conservative. Third one is Conservapedia and Rational Wiki. These two websites are self-identified cross-source-based encyclopedia website for conservative and liberal, respectively. For each of these three datasets, we train machine learning models and then test on the other two datasets and report you the average performance. And we apply three different machine learning models in this experiment. First one is TF-IDF and logistic regression. This is a bag of n-gram linear model. Second one is recursive autoencoder. This is a neural network-based nonlinear model. With these two models, we just train based on our source dataset and test on the target dataset. However, there is one potential problem here. One of the most fundamental settings for machine learning problem is that the training dataset and the test dataset should be sampled from the same distribution. However, due to the fact that our dataset come from 3 different sources, so our data is actually sampled from different distributions. So we use domain adaptation technique here. In our case, we use marginalized stacked denoise autoencoder, MSDA. MSDA is considered as one of the most classic domain adaptation technique for text data domain adaptation. And here are the test results. Each number is AUC value based on the test set classification result. Let's first take a look at the cross-validation result. As we can see here, all 3 cross-validation results for all 3 datasets are all excellent. However, the naive cross-domain classification results are all very bad. In most of the cases, they are just around random guess. Even with the domain adaptation technique help, the results are still not very promising. The best performance we can get is when we use Congressional record as training data and test on Salon and Tongho dataset. So there are multiple hypotheses that could lead to this unsatisfactory result. One potential hypothesis is that the specific concept behind these 3 datasets are actually different. And to investigate this hypothesis, we designed and run following experiment. Here is the experiment we did previously. We used Congressional record and training dataset and test on the Salon Tongho dataset. We randomly sampled the sum of Salon Tongho dataset in the test data and move it from test data to training dataset and combine with Congressional record to be a new training dataset. If the specific concept behind Congressional record and Salon Tongho are consistent, then by including Congressional record in the training dataset should be helpful with the test performance than the experiment when we only use the same portion of Salon Tongho dataset in the training data. And here are the results. X-axis is the ratio of how much Salon Tongho dataset we use as training data. Y-axis is the AUC value. Blue line here is the cross-validation for Salon Tongho dataset, in which case we do not use any Congressional record data in the training dataset. Green line here is the result based on MSDA method, in which case we use all the Congressional record data in the training dataset. As we can see here, blue line is better than green line with a large margin. Which means by including Congressional record data in the training dataset is actually harmful for the performance. Therefore, the concept behind Congressional record and Salon Tongho are different, and the hope of successful cross-domain classification is significantly diminished. Now we know that it is the specific concept, the differences that lead to the bad performance. Can we do something to improve it? Our idea is that probably for some topic, the specific concept is more consistent than the other topics. So follow this idea, we run a topic model. We train an LDA topic model with the dataset including all Congressional record and Salon Tongho together with 40 topics. Then after this, we classify all the articles in Congressional record and Salon Tongho to one of these 40 topics. Therefore, for each topic, we have 2 piles of data, one for Congressional record and one for Salon Tongho. And then, next step, we run cross-validation within each topic for Congressional record. And the next step, we rank all the topics with respect to the cross-validation accuracies. And the third step, we train the classification model based on the Congressional record data within one topic, and test on the Salon Tongho data with the same topic. And here are the results. X-axis is how many topics are considered in terms of the cross-validation accuracies from high to low. Y-axis is AUC number. For example, the upper left point here is the case when we only consider the top 5 topics with highest cross-validation accuracies. As you can see here, these results show us that the higher cross-validation accuracy topic will lead to higher cross-domain test accuracy. And we repeat this experiment and in a reverse way that we train based on Salon Town Hall and test on Congressional record, and we observe the similar result pattern. And one more point I want to deliver is that the absolute AUC value for the first group is better than the second group with a large margin. We investigate a little bit, and we find out that it's probably because there is actually a language flow from Congressional record to Salon Town Hall. The detail of this language flow experiment is in our paper, and if you are interested, please refer to our paper. And here are the 5 topics with highest cross-validation accuracy for Congressional record. We can see a lot of substantive topics here, like politics, economic, healthcare, taxes, climate change, so on and so forth. And here are the 5 topics with the lowest cross-validation AUC. As you can see here, there is still one substantive topic, abortion, here. It could be the case that the discussion among the members of Congress was not distinct between 2 parties when these speeches about abortions were delivered. And of course, we can see some uninformative topic like procedure phrases here. Okay, now, based on our previous experimental result, we know that cross-domain partisanship classification identification is hard. Our next question is, suppose we can constrain the source of the data, for example, the same group member of Congress. Do they express their ideology consistently across different domains? To investigate this problem with machine learning, we designed around following experiment. We target 113 House of Representatives, and we collect 2 data sets associated with them. First one is Congressional record, which is the speeches delivered by the 113th House of Representatives on the floor. And the second one is press releases, which is their official announcement posted on their website. These 2 data sets can all be considered as the expression of their ideology of the same member of Congress, member of Congress, but in different venues. We also use a baseline here, DW nominal score. DW nominal score is a well-known measurement for the partisanship intensity for member of Congress. It is calculated based on their voting history on the floor. So to obtain the ideology intensity score for member of Congress based on the text data, we run leave one out experiment. We first connect all the speeches belongs to the same member of Congress together. And for example, in order to get Charlie's score, we will train a regression model based on all other member of Congress data and use the DW nominal score, use their ground truth DW nominal score as the regression target, and then test on Charlie's data. And finally, we can get the output will be used as the regression result for Charlie. And we repeat this process from Alice all the way to William until we get basically for all the members of Congress. And here are the results. X-axis is the regression score we get based on the leave one out experiment for Congressional record, and the y-axis is DW nominal score. Each dot here represent a member of Congress. Blue dot is Democrat, and the red dot is Republican. And as we can see here, first, based on the regression scores based on Congressional record, the Democrat and Republican are separately Basically, it means based on this text data, the House these House representatives express their partisanship very clear. However, our score and the denominator score are not consistent very well. To see this, suppose we have two members of Congress here, Bob and Alice. According to denominator score, Alice is more liberal. According to our score, Bob is more liberal. And this inconsistency is all over the place here, obviously. And we repeat this experiment for press releases, and we observed a similar result pattern. And finally, we compare the result we obtained based on Congressional record and press releases. To our surprise, given the fact that these two data sets come from the same source, same group member of Congress, these two score lists are not consistent as well. This result actually shows us that according to these two data sets, they express their partisanship intensity differently in different channels. So the takeaways for our paper is the cross-domain partisanship generalization is a very hard task. Second, for some topic, the cross-domain predictability is significantly better than the other topics. Third, legislators communicate differently through different channels, and they are likely use these channels to reach different constituencies.